Hello guys, welcome back.
Hi, sir.
Right. Okay, so today we have topic 5 and 6. Right. No. Not 5 and 6. 5 and 6
Sir,
is
it's
last
7
time.
and 8.
7 and 8. Yeah. Good. All right. Let's see. Grab this thing. All right. The difference between presentation drawings, design drawings, and the construction drawings. That will be for topic 7. And virtual reality versus mixed reality versus augmented reality and its application in architecture. That will be for topic 8. So I only see a few people here. I guess everybody is on their way virtually. So let me give you just message the group and just tell them that we want to start. We might let me see what else is on the schedule for today. What else is on the schedule today? Right. So today is the 13th, right? So yeah, okay, yeah, we just have the student presentation. So potentially we probably have a short class today actually. Next week we're going to start the studio base. We're going to get issued the studio base project. Not next week, sorry, week after next, right? Yeah. And then we're going to go into checkpoint 4. What's happening for the next lecture class? The next lecture class is going to be, we're going to jump into talking about exterior photorealistic images in Twinmotion, right? And the one before that is going to be, right. So today, all we have to do today is do the presentations, and that is it. We have no more topics to unveil. So it's just a presentation and any questions that you might have relating to the major project, right? Then next week is holiday, and then the week after that, we're gonna jump into the studio based. We're going to talk about interior design basically. And if you notice on the mirror board, there's a bunch of some really awesome interior design tips, especially having to do with kitchen. There's a focus on kitchens because that's what we're focusing on. So you guys don't have any excuse but to have the very best kitchen design in your design studio project. Right, Webley?
Right, so.
All right. But we're going to move into that stuff week after next week. All right, we're going to render interior image. We're going to learn about interior rendering and lighting and all that fancy stuff, and learn a little bit about interior design, focusing on the kitchen. And yeah, and the idea is for you to use that in your project. Oh, by the way, so you guys know what project, what type of housing project you're doing now? Is it apartments or townhouses? Guys, anybody?
It has a commercial aspect to the bottom and to the top is the housing.
So it's a mixed use?
Yes.
Interesting. Okay. Cool. All right. Okay, so is group 7, topic 7. Ready?
Whenever you are, sir. Whenever you are.
All right, cool. So let me stop my share so we can just jump right in. All right. Did I stop my share? Yes, I did. And let me get out my
Can you see my screen?
Yes, I can see it.
Okay.
Okay. Hang on a second. Let me just ready up myself as well. And this is 7, topic 7. All right. And everybody else can ready up yourselves. Remember, we're going to be doing questions. And we definitely want to be on time this time. Definitely. So, all right. Go ahead. You can begin.
Can you hear this?
Yes, I heard a little pop.
You can't hear it loud? You can't hear it, right? The background?
Yes, but I don't know if I'm hearing it through your mic or I'm hearing it
Okay,
through
let me see if I shared my sound.
Right, so I need to share your sound as well.
Okay, there you go. Let me know. I'm gonna mute and you can tell me if you can hear it.
Good. Good to go. I can hear it.
Okay, thank you very much. All right.
So good afternoon, everyone. Today, Group 7 will be presenting on the differences between presentation drawings, design drawings, and construction drawings, and when to use. The group members are Addison Williams, Marvel Williams, Turan Harrison, myself, Shania Proctor, Daniel Wesley, Shay Francis. Now we move into the agenda for the day.
And take down the music just a touch so I can hear your voice. Down. Talk, let me hear.
Now we move into the agenda.
All right, that's good.
So now we move into the agenda for the day. First, we'll begin with presentation drawings, design drawings, and construction drawings. Buckle up because we're about to explore this from the ground up.
Okay, so drawing plays a vital role in the built environment and is arguably the most essential element within the profession. It serves as a universal language that connects all disciplines, enabling the communication of ideas, solutions, and instructions. Drawings can be classified into various categories based on their purpose and application. This presentation aims to distinguish among design drawings, presentation drawings, and construction drawings while providing examples and explaining the appropriate use of each. Presentation drawings. Presentation drawings are visual representations of an architectural design that communicate the overall concept, form, and feeling of a project to a client, jury, or the public. They are the final stage of an architectural drawing before approval or construction. They're meant to persuade, impress, and clearly express the design intent. These drawings translate technical plans into aesthetic, readable visuals that help others understand the design's purpose, atmosphere, and functionality. What is the purpose or are the purposes of presentation drawings? Presentation drawings serve several key purposes. Communication. This clearly expresses design ideas and concepts to clients, investors, or review boards. Visualization. This helps non-architects visualize the spatial relationships, materials, and overall appearance of the building. Decision making. This aids the client in understanding design alternatives before final approval. Marketing and promotion. It's used in competition, exhibitions, or client pitches to showcase creativity and professionalism. Documentation. This provides a polished record of the design process and final outcome. Now we move on to types of presentation drawings. We have two-dimensional presentation drawings, which includes site plans, which show layers of buildings, floor plans, which represents the arrangement of spaces, elevations, sections, which reveal the interior relationships. And these two-dimensional drawings, they focus on layout, proportion, and design clarity. Three-dimensional presentation drawings. These include perspective drawings, which can be hand-drawn or digital, isometric drawings, which show 3D form without distortion, render 3D models or physical models, which can be scaled, and tangible representations for display or review. And lastly, we have mixed media presentations, which often combine digital renderings, diagrams, infographics, or animations. The essential components of presentation drawing. These include, as shown on the screen, title blocks, plans, elevation sections, perspective renderings, concept diagrams, material palette, annotations, legends, and so much more. So the tools and materials used. We have traditional, which also known as manual tools such as tracing paper, watercolors, color pencils, scale rules, set squares, and so on. And for the digital tools and software, those include AutoCAD, Revit, Rhino, Twinmotion, Photoshop, and the famous InDesign. How do you present presentation drawings effectively? Firstly, you keep the layout clean and minimalistic. Let the drawings speak for themselves. Maintain a consistent color palette and font style. You will include human figures, trees, and shadows for scale and realism. Label all drawings neatly, avoid clutter, and practice your verbal presentation. Explain the concept, not just the visuals. Lastly, here are some additional notes. Presentation scales usually ranges from 1 in 20 to 1 in 500 depending on the drawing type and the purpose. Your audience matters, so tailor your presentation style to who you're showing it to, whether it be a client, lecturer, or competition jury. Sustainability and context are often included in modern presentations to show awareness of environment and culture. And lastly, your presentation boards or slides are usually arranged to tell a story, from concept to site, to design development, to final visuals.
Now we'll be taking a look at design drawings. What are design drawings? So these are conceptual and schematic drawings or illustrations that develop, explore, or refine your design. And those are the three key words used in regards to design drawings and defining them. Develop, explore, and refine. Your key audience here would typically include designers, fellow architects, tutors, other collaborators of this project. And your focus for design drawings will be exploring and testing your different ideas and options, form, space, materials, relationships, etc. Common types of drawings included in this stage include plans, sections, elevations, sketches, overlays, physical or digital models, exploded views, diagrams, etc. When to use design drawings? So you use them when you want to develop, explore, and refine the design, from concept sketches to detailed design decisions. Your goal here is to solve design problems and define architectural intent. At this stage, you want to think, how do I determine what works spatially and technically? Let's look at some legal requirements that might be involved in design drawings. Although most of the legal matters take place in, in construction drawings, you still want to consider some of them throughout the entire design process. So firstly, we have zoning and land use regulations. Even at the design stage, you should make sure that your proposal fits the rules for that site. So like what type of building is allowed on your site, residential, commercial, etc. Building height limits, setbacks, parking or green space requirements. Then you want to consider building codes, fire safety, accessibility, ventilation and lighting requirements, structural safety. Property boundaries and easements. Design drawings must respect legal boundaries of the property and any easement, that is, areas reserved for utilities, drainage, access. Designing over these can cause legal disputes or permit rejections. Then you have environmental or heritage regulations. So sometimes your site might fall on protected land, environmentally protected or historically protected land. So you want to ensure that your design accommodates such accordingly. So that may include minimal environmental impact, respect for any historical character or style that may exist on your site. And then last but not least, we have intellectual property or IP rights. So this is kind of like plagiarism. Others cannot copy or build from your design without your permission, and vice versa. You cannot copy from another architect's design without giving credit or without his or her permission.
Examples of floor plans and elevations. Floor plans, visualizing space and functionality. For floor plans, it shows the arrangement of rooms and space within a building. It is essential for understanding layout. For elevation capturing architectural details. Elevation provides a 2D front view of representation of a building exterior. It communicates its building appearances, structure details to clients and construction workers and other authorities. Examples of drawing types using design drawings. Sections shows vertical cuts of building revealing its interior structure, spatial relationship, materiality layers in a way that is not visible to plan or elevation. Perspectives, it creates a realistic three-dimensional 3D view of a design of two-dimensional surfaces, allowing architects to communicate their vision. Lastly, exploded diagrams. In order to assemble, highlight hidden details and specific understanding of structural system, spatial organizations for clients and teams.
Now let's dive into construction drawings. What are construction drawings? Construction drawings are drawings that are used to give detailed technical information or instructions to the builder to construct a building or structure. There are different types of construction drawings, and they entail site plans, which shows the building position on the site, floor plans, which are horizontal sections that show the layout, dimensions, walls, and doors, elevations, which depict the exterior appearance of each side of the building, showing height, material, and finishes. Detailed drawings, which are enlarged parts of the design to illustrate the construction of joints. Roof plan, which show roof shape, slope, materials, drainage, and openings like skylight. Electrical and plumbing layouts, which indicate circuits, fixtures, and service routes. Structural diagrams that provide specifications for beams, columns, foundations, and roofs. Purpose of construction drawing. They serve as a guide for builders and contractors during construction, communicate precise technical and design information, ensure coordination among disciplines, architecture, structure, and MEP. Now move on to the essential components, which are the title blocks, which provide project info, scale, and drawing number, note arrows, scale bar, and dimension lines. Also notes and annotations for materials and finishes. The importance in construction process is accuracy and clarity, errors and disputes, building approval and inspection, communication bridge, maintenance and future renovations. Standards and conventions are normally the use of architectural scales in 1 to 100, 1 to 50, 1 to 20, and so on. Layer organization in CAD or BIM systems, compliance with local building codes and drawing standards, example, the ISO, BSI, and the GIE. Consistent line weight, symbols, and annotations are needed for clarity. The coordination and collaboration deals with how do architectural drawings align with structural, mechanical, and electrical drawings, importance of revision control and revision management, role of drawing sets in tendering and site meetings.
Okay, so here shown on the screen, what we wanted to do is demonstrate some of the working drawings or some of the drawings that we had done. So Thiran, a member of our group, had done some sketches for us. And here seen is a ground floor plan and a first floor plan side by side to show the layout of the space. Sorry. Secondly here, we have a perspective drawing, which is at an angle, and we just wanted to show how the structure would look if it realistically, right? And a front elevation to show its makeup. Okay, I mean, this is quite self-explanatory, so we'll just move on past this one here. Okay, so another group member of ours was able to get some actual real-life drawings that were used to build that structure. So these are construction drawings, as you can see, because you can see the dimensions and it shows how it's gonna be built. So I just want you guys to take a good look at these drawings that I'm about to show you. So first off, it's a site plan. I hope you guys can see this at the bottom of the screen are the different details. So all of the tier is not for the clients themselves to see, but more for the what do you call them, the contractors to be able to use.
If I may help, Adi. Yes, so some of these drawings are just showing you the different elements of the construction drawings. These that are showing now is the structural drawings for the building that the builders will use to carry out the construction of the, putting the structural steel and the fabrication of the steel work. Next. This contains also structural drawings. The structural engineers would have been doing. These show the details as it relates to the drainage system. Can continue. Septic tank and the soak away. Yeah, so the drawings, as we said, are essential for the construction of the building, and so those drawings aid one person to carry out what needs to be done. Now, things that you use to carry out construction drawings, I guess if in time past we used to use if you want to do it by hand, then T-square, set square, all of these different pencils would have been very essential for these outputs. But of course, in the digital realm, then we probably use programs like AutoCAD, I guess SketchUp, get to understand, and Revit now. So these are different ways that we can now produce these drawings.
Thank you, Villa. Okay.
I cannot stress this enough. Sketchbooks are absolutely essential for the design process. You must use them.
Okay.
Yes, guys. Yes, guys. It's not rocket science. Your sketchbook is important for any of the design drawings or any form of these drawings that you're doing. So yeah, sketchbooks are very important no matter what process you're in. They're the drawings, whether it's presentation, construction.
I cannot stress this enough. Sketchbooks are
Okay, so what we want to do here is compare digital and hand-drawn drawings. So digital drawings involve the use of technology or software to develop visual content, design, presentation, and construction drawings, whereas hand drawings use traditional materials such as paper and pencil, pen, marker, etc. Okay. Okay, here we just want to compare the two, the digital drawings and the hand-drawn drawings. So digital drawings are highly precise and accurate, fast revisions and edits, good for technical details on construction docs. They're flexible, they're easy to collaborate with, and good for documentation. Whereas hand drawings, they can be less precise and require skill, right? So they're stronger artistic expression and creativity. They're visually engaging. They're quick for brainstorming, and obviously, it requires no technology, and as many would say, it's a lot cheaper. So the key takeaways for this would just be digital precision. Digital means precision, efficiency, and technical use, whereas hand-drawn is creativity, concept development, and expression. The best practice is to combine both, sketch concepts by hand, and finalize digitally. So for learning and skill development, digital drawings develop skills in CAD, software, BIM, etc. It requires learning software and specific workflows, whereas hand-drawn builds fundamental understanding of basic principles and strengthens freehand skills and conceptual thinking. Digital drawings are best used for construction documents, BIM coordination, and technical detailing, while hand-drawn is best used for concept sketches, ideation, visual storytelling, emphasizing mood for architects and collaborators. The disadvantages of both: for digital drawings, first, costly. The learning curve is less expressive. and there's an over-reliance on technology. For hand-drawn, it is limited precision, it's harder to edit or revise, it's time-consuming, and there's no automatic duplication or scaling, and it can get easily damaged or lost.
Okay, so bringing everything together, the process in which everything happens in terms of design to the finished product. Firstly, you have the design stage, your design drawings. This is where you coming up with ideas, where you're exploring, developing, and refining. And then once you have something substantial to present to your clientele, this is the point where you're selling the vision, you're selling the idea, and you may go back and forth between the design and presentation stage. Maybe the clientele wants to change something, so you go back and change something, then you bring it back to them and you sell the vision again. And then after all of that happens, you move on to what should ideally be the final stage after you develop your construction drawings. Ideally, you don't want to have to edit anything or go back to anything, because this is a point in which after your construction drawings, you will begin to build the design. However, sometimes things happen in the real world, and sometimes you end up having to go from the construction stage, even after construction has begun, back to your design stage. Perhaps the client changed their mind about something, so you got to make that quick edit, or budget adjustments or site conditions. God forbid someone measured something wrong incorrectly on the site, so you have to make that adjustment. Building code, coordination with engineers, consultants, and many other reasons. And to break it down and for a better comparison of presentation, design, and construction drawings. For the purpose for presentation, as we've mentioned, is to sell or express your idea. For design, it is to develop or refine the idea. And for construction, these are the instructions to build the project. Your audience for presentation most likely will be your clients, juries. Design, it will be your fellow architects or other collaborators involved in the project. Then construction, you have, of course, your construction workers, engineers, contractors. Tools commonly used but not limited to each. You have Photoshop, Illustrator, SketchUp, Revit, AutoCAD, hand sketches, and similar tools are used for construction. Scaling, approximate for presentation, consistent for design, and of course, exact for construction. All right, so as we wrap up, we have a little engaging activity for all of you. I'm going to read scenarios, and you're going to tell me if it's design, presentation, or construction drawing. I put together a mood board to help me visualize my spaces. Is this a design drawing? Is this mood board a design drawing, a presentation, or construction drawing? Any guesses?
Guys, you can open your mic and answer us, please. Thank you.
Is it design, presentation,
Here
or
what we're going
construction?
to do. Let's ask that in the Q&A section. So we ask them in the Q. How much questions do you have to ask?
Just 3.
Just 3.
All right, cool. So here what we'll do. So we can group 7 would like to give away 3 questions to make the question asking process easier. But very good, very good that you asked some questions. So we'll answer later, but still continue to the next one, and so we can get a look on it, and then during the Q&A we will we'll answer it.
That's the
Oh,
answer.
you're
The
giving me
answers
the
are in the
answer. Oh, the answer.
Yes.
Oh man. All right, cool. All right, it's fine. Go ahead. Just continue.
Okay, so if you guessed design, that
Mhm.
was correct. Ooh. The next one, I am adding dimensions to show that a steel beam is 200 millimeters deep, centered 150 millimeters from the wall. Design, presentation, or construction?
I think it's construction.
Yes, good job, random person.
Yeah, oh my
Construction.
gosh.
And last question. Showing the client a drawing that shows the client how lighting filters to the building's central atrium in the afternoon. Design, presentation, or construction.
Could it be presentation?
Good job. Yes, it is presentation. So
Great.
that concludes our Group 7's presentation. Thank you.
All right, guys, good work. All right. Now it's time for Group 8, aka Topic 8. You ready for me, Group 8? Who's here from Topic 8?
So we're here.
Oh, you just readying up. All right, cool. All right. No problemo. Well, I guess everyone will have to come up with their own questions, as there were no free questions given away again from Topic 7, right? Which is good.
Give us a second, sir. Our main presenter's Wi-Fi is coming in and out, so we're using somebody else.
Oh, yes. Welcome to technical challenges. All right, cool. While you guys ready up, for Design Studio, what type of drawings do you do for Design Studio? Is it presentation drawings or design drawings? All right, you know what? Stick a pin on that question until after the presentation. Also remember, if you're having trouble sharing with the internet speed, I can share it for you, and you just tell me when to go next, if that helps.
Good afternoon, everyone. So this is Group 8's presentation on extended reality technologies in architectural design. The group members are myself, Abigail Watson, Adriana, Leona, Mateo, Michaela, and Shaquille.
So extended reality, VR, MR, and AR. Classifications. What's the difference between virtual reality, mixed reality, and augmented reality? Comparative. Which extended reality is best for architectural design?
So we have virtual reality, which is a fully digital and immersive environment where you can walk through and experience a building before it is even built. Architects can use it for design walkthroughs, client presentations, and testing things like scale, materials, and lighting. A common software includes Enscape, Twinmotion, Lumion, Unreal Engine, and Unity Reflect. And the hardware usually involves VR headsets like Oculus Rift and HTC Vive. We have some images, an image of a person using a VR headset on the top left. Then we have the augmented reality or AR. So this works differently because it overlays digital models onto the real world using a phone or a tablet. It's useful for an on-site visualization and client demos. And it allows you to see how a building or design will fit in its actual environment. So popular AR tools are Archi, Morpholio, Sketchwalk, SketchUp Viewer, AR, and the Well. And for the mixed reality, it combines both real and digital elements that interact with in real time. It often used for collaboration and construction visualizations, helping the teams to see how the building systems are, the structural elements, and how the design fit in real spaces. So common mixed reality software, Trimble Connect MR, Visual Live, Fuser MR, and the Well. And the main hardware is Microsoft HoloLens. And then Leona will take over here in the application.
Yes, so the application, the uses of technologies. So the different uses of virtual reality, augmented reality, and mixed reality. So the application is not only used in architecture, but in different areas such as architecture, education, tourism, and entertainment. In architecture, we can use it for the virtual walkthroughs of buildings before construction. Clients can experience the spaces at full scale. In education and training, it creates a stimulated environment for pilots, surgeons, soldiers, or engineers to practice safety. In tourism and heritage, virtual tours of historical sites, for example, we're currently doing Port Royal. You can use it to experience the space before the earthquake. In entertainment, we can use it for gaming, 360 movies and concerts in the virtual world. In healthcare, we can use it for pain management, phobia therapy, or rehabilitation using immersive environments. Augmented reality in design. So in architecture, we can use it for viewing 3D models over real sites through a phone or tablet to visualize scale and placement. Retail, virtual try-ons for clothes, makeup, or furniture. In education, you can use it for interactive learning where students see labeled autonomy for planets through their devices. Navigation, real-time directions and labeled overload on streets or building. Maintenance and repair. Technicians see digital instructions directly on the machinery they're fixing. For mixed reality in design, architecture related, designers can place and modify holographic modules in real spaces, collaborating remotely. In manufacturing and engineering, workers visualize components inside machinery or test designs interactively. Medical training, surgeons practice procedures for holographic autonomy models, overload on real equipment. Remote collaboration, teams across the world share and manipulate 3D models as if working in the same room. Education and research, students explore scientific stimulations that respond to their movements or gestures.
So here we have devices used with extended realities. So we're going to look at what devices we can use to experience the technologies, such as the virtual reality, augmented reality, and mixed reality. And we're going to see how these technologies allow architects to visualize and experience their designs in immersive ways, and how does each experience differ? So we're gonna look at the hardware for virtual reality. So virtual reality offers a fully immersive experience. So this requires specialized hardware such as virtual reality headsets and motion controllers to provide an optimal user experience. So some examples are like Meta Quest 2 and Pico 4 and PlayStation VR 2. The hardware for augmented reality now. This overlays 3D models into the real world and use devices such as smartphones, tablets, so that creates an enjoyment for the general public. So for the optimal user experience, it is recommended that devices have a good camera and a high quality display. So some devices come in the form of glasses like Vozix or Epson Movero. And for hardware for mixed reality, this blends the real and virtual worlds. So to experience mixed reality effectively, you need a specific high-end device, which is very expensive. And currently the most common devices for mixed reality are the Microsoft HoloLens and Magic Leap 2. And these devices come with built-in cameras, sensors, and high-resolution displays, which is why it's so pricey, to provide a more complete interaction with virtual elements.
So for extended reality application, how does virtual reality, augmented reality, and mixed reality aid in architectural design and thinking? The aid of virtual reality in design. Design development and spatial validation. VR allows architects to walk through space at full scale, testing circulation, proportion, and spatial feel. Zaha Hadid architects use this to refine museum layout based on real-time spatial experience, not just drawings. Clients communicate and decision making. Firms like Glenster use VR walkthrough to help clients compare design options, for example, kitchen layouts, in an immersive way, leading to faster approval and faster revision. Materials and lighting studies. Designers can adjust material finishes and lighting in real time. Firms like Foster Plus Partner use VR to test daylighting and facade materials for aesthetic and energy performance. The aid of augmented reality in design, site analysis, contextual design, AR visualize massing studies on site, showing how proposed building relate to surrounding, views and shadows, impact offering insights hard to get from plans alone, while design overlay for renovation. AR lets architects overlay new elements like windows onto existing structures in real time, aiding renovation and preservation. Projects by ensuring design compatibility with original architecture. Real-time stakeholders review during site visit. Architects can use AR to address concern instantly, while showing live shadow studies or design response to communicate our planning authorities' feedback. The aid of mixed reality in design, collaborative design in mixed reality. Using HoloLens, teams can manipulate shared 3D models in real time, improving coordination across discipline. BIG, Barak English Group, known for architecture, product, landscape design, and planning, has used this for complex projects collaboration, full-scale prototyping without construction. MR enables life-size virtual mock-ups like hospital room, allowing end user to test layout and catch design issues early while saving time and cost. Structural and MEP coordination. Architects and engineers can overlay system in MR to identify clashes like beam versus duct before construction, improving the accuracy and reducing rework. Interior and furniture layout. MR let designers place and adjust virtual furniture in real room, helping client experience layout, proportion, and aesthetic at true scale. Aided applications support design thinking. What makes these technologies powerful is how they change the design feedback loop. As we compare and contrast, you will notice how traditional process entail design, draw, image, build, and discover problems, while VR, AR, MR offer design experience, refine, build, and fewer surprises. Catching errors early, spatial issues become clear in immersive 3D, not just 2D plans, acceleration decisions, stakeholders grasp design faster, cutting down meeting time, while enable broader input. Clients and users can give feedback without reading drawings. Testing multiple options, easily compare and experience different design scenarios, while connecting virtual and real. AR and MR link digital models onto site connection. Sorry.
This was a video to show how the virtual reality is in with twin motion.
So as for the future of VR in architecture, this section we're going to be taking a look at the future of VR in general, but in more specifics, VR in the architecture industry. So as it relates to the future of VR, slowly but surely it's becoming a more integral part of our everyday life. So it is a very powerful tool that is transforming how we learn, work, design, and communicate. And it's projected that the virtual reality market is expected to reach a value of 123.06 billion by 2032. So some areas where developments are being made in VR technology are one, VR hardware advancements. So vendors like Apple are introducing incredible tracking capabilities and Primark's introducing retina level displays. Another area of development is growth in software ecosystems. So vendors are seeking to expand available app markets for enterprises, companies, or just the everyday user. There's also advancements being made into the intersection between AI and VR. So in vendors developing their VR headsets, they're looking to integrate artificial intelligence in having maybe a virtual assistant or autonomous AI in their VR apps. Another area of development is expansion in MR and AR capabilities. So while companies are looking to transform, training, collaboration, and project development strategies, sometimes a full immersive experience isn't ideal or the best case to use. So some vendors are looking to make their devices more versatile, allowing them to implement flexible options, for mixed reality and augmented reality into their VR headsets. And finally, for more advanced accessories, vendors are looking to develop gloves, bodysuits, even armbands that will help boost immersion. And so more specifically, as for the future of VR in technology, as architect Peter Toohey quotes, VR is here to stay. Those who use it will prosper. Those who don't will sooner or later find it impossible to compete. He says that far less talented architects offering VR will easily win jobs from their more talented competition. This is why every architect must learn VR. So as it relates to VR in architecture, you can now create more accurate designs, spot potential issues before construction even begins. You can engage clients in ways that were previously impossible. And with advancements in both hardware and software, VR will offer more lifelike simulations, giving you the ability to test everyday aspects of design. So areas where VR will impact the future of architectural design is, for one, it will foster better communication. So this will allow for, while traditional blueprints and 3D renderings can convey spatial relationships, lighting conditions, things like that, VR will immerse the user in realistic simulations of the space. So particularly for clients, this will allow them to step into maybe their future home, maybe their future office, feeling proportions and even adjusting design elements like on spot, allowing maybe like wall colors or furniture, just allowing it to be a more interactive and then for them to connect with the design better. Another impact it will have is in reducing waste and promoting sustainability. So augmented reality and VR serve as a valuable tool in green transitioning by allowing designs and construction teams to design and optimize buildings while minimizing waste and reducing energy consumption. So architects can simulate daylight to optimize natural light to give clients a feel for the spaces that may otherwise need to be modified upon completion. Construction teams as well can use augmented reality to do the same by precisely positioning elements like beams, walls, and utilities. So these processes will optimize design and reduce waste during construction. Another area is improved and more interactive student learning. So as we all know, in particular for us as architecture students, studying architectural precedents is an essential part of our education. But however, due to either geological constraints, financial or logistic limitations, we can't necessarily be able to go to and visit and experience every precedent that it is that we study. So VR, the developments that are being made now offer immersive experience allow students to virtually explore architectural precedents from anywhere in the world. Also, heritage sites that are at risk due to environment or human factors can also be digitally preserved and allow us as students to experience them without the hassling of putting said sites at risk. And finally, public engagement. So this advancement will offer opportunities around public engagement in architecture that could advance inclusion and equity in the design process. So what we're talking about here is how everyone will have the ability to experience and provide input on designs within reason, of course, and in relation to architecture and urban planning, and it becoming a more collaborative endeavor. So architects and planners can simulate cities, enabling communities to understand proposed developments, participate in decision-making processes. So, for example, urban planning renewal projects similar to what we're kind of doing in Studio with Port Royal now. With the use of VR, we'd be able to implicate large and diverse populations and can allow people to use VR to enable users to experience and interact with the proposed developments being made to the built environment.
Okay, so the pros and cons of VR in architecture representation, the upsides, the splendid advantages of virtual reality in architecture representation, and the downsides. What are the disadvantages to using virtual reality in architecture representation? All right, so immersive previews. VR lets users experience spaces before construction, offering better spatial understanding than drawings or static models. So VR enables users to experience a building as if it were already constructed. So instead of imagining spatial relationships from plans or renders, clients can walk through rooms. They can look around corners and feel the scale and the ambience of the place. This is especially powerful for conveying emotional resonance in spaces. Clearer communication, complex designs become easier to grasp for non-specialists through interactive environments. So architects often struggle to convey spatial ideas to non-designers. VR bridges that gap by translating technical drawings into lived experiences. So a client who doesn't understand section cuts or axonometric views can still grasp the flow of a space in virtual reality. Instant design feedback, real-time changes to lighting, materials, and layouts enable quick iterations and better decisions. So you can stimulate the lighting changes, material finishes, and circulation paths in real time. For example, testing how daylight filters through a courtyard or how a visitor moves through a memorial space becomes more intuitive, you know? Where am I? Enhanced client engagement. Virtual exploration fosters stronger client connection, faster approvals, and fewer misunderstandings. So VR makes presentations more memorable. So clients feel more involved and emotionally connected to the project. This often leads to faster approvals and fewer revisions as they have already air quotes, or lived the design. Remote collaboration. VR supports virtual walkthroughs for dispersed teams, improving coordination and feedback. So with cloud-based VR platform, teams across the globe can meet inside a virtual model. And for us, like Abigail explained earlier or mentioned, you could walk like one of our lectures through our Port Royal urban housing with VR. All right, so the cons. All right, so disadvantages in virtual reality with architecture representation. So high upfront costs. VR requires investment in headsets, powerful computers, and software, posing challenges for students or small firms through budget-friendly web tools, though budget-friendly web tools exist. So as you know, these things are expensive, this can be prohibitive. However, some platforms offer lightweight, like browser-based VR, for example, Floor Planner that might be more accessible for academic projects, technical learning curve, integrating VR into workflows, example, Rivet, takes time, often involving trial and error and ongoing support. So, learning to use VR platforms demands time and effort. Integrating these tools into existing workflows, especially within Rivet or mapping environments, often involve trial and error, which can disrupt like creative momentum and require ongoing technical support. Limited accessibility. Not everyone has VR hardware, so inclusive alternatives like video walkthrough or web-based panoramas may be needed. So to ensure inclusivity, designers may need to offer alternative formats such as video walkthrough. Yeah. Risk of potential overload visually. So flashy VR visuals can distract from deeper design meaning, potentially reducing cultural or functional depth. For architects focused on identity and memory, it's important to maintain narrative depth and avoid reducing spaces to mere spectacle. User discomfort. VR can cause dizziness or fatigue during long sessions, limiting its use for extended reviews or public engagement. This limits its practicality for prolonged design reviews or public exhibitions where accessibility and comfort are key. Slide. And here ends our presentation. I hope you guys grasped something from it because like it is required, we're gonna ask questions. So I hope you enjoyed that. And these are references.
All right, good. Thank you. Thank you very much. All right, so general comments. All right, so let me start with the last one first. So for VR, MR, and AR, right? Well, definitely I appreciate your slides and the way how you presented. Yes, there were 1 and 2 pauses. I think the slide designs were very good. You chose appropriate pictures and all of that. My main thing though is that VR, AR, and MR is such a tricky topic for you to convey visually, right? And you know why, right, guys? Why is it so hard?
Because you don't have the actual
Exactly.
hardware.
Exactly. So as tricky as it is to communicate, I would say that most of the examples that you say, like I know because I've experienced it, right? Many times. But I think you needed to try with some video examples. You did have a video example, which is good. One dege video example. Especially with MR. Like MR and AR is tricky to understand because they're not popular. Most of us use VR, which is why I would say that your presentation was kind of VR heavy. But I'm wondering is there anybody that has heard of MR for the first time? Mixed reality. Anybody? Anybody in the class? Apart from obviously not a part of the group. Anybody ever heard of MR? So this is your first time? So everybody here is the first time hearing of MR. Hold on there. Where's this thing? Right? Francis, first time hearing of MR?
Yes, sir.
Can you explain from your imagination from this presentation what you think it is? How you think it work? Try?
Sorry, please can somebody else.
Well, it's okay if it's tricky to explain because it is. Hence, this is the challenge for this group. So anyway, I'm still giving feedback. So that is one thing I would say. I would say that some more examples to help us fully understand, right? Now, um, that's mixed reality. Okay, AR, augmented reality. Anybody ever hear of Pokemon Go? Maybe you don't play it, but you hear of it? See it on the news? See it somewhere?
Yes, sir.
See somebody playing it? Yeah, that's AR. So there are some very practical uses of AR around us. Anybody ever went on Amazon on their phones? Of course, everybody here must go on Amazon at some point, but on their phone. Anybody? Um,
Sir, are you referring to the, like, if you select a certain product, you'll be able to like
right,
see 3D?
right. Have you ever anybody ever tried it out? You know, like people in the group that are presenting on AR?
Yeah, I have before.
Okay, good. So what the example there?
It's in Snapchat too, sir. Sometimes Snapchat have what do you call it?
Oh, I
Like you
didn't
can
know
put
that.
down like a dinosaur or something on the ground.
Ah, cool. Exactly. So I'm saying that when you're explaining it, so that is, I know not everybody here probably use Snapchat and not everybody here use AR, but I'm trying to give you guys a kind of visual example of of how it work, right? Because yes, we looked at some of the advantages, disadvantages, but just exactly what it is. And all it simply is you looking through the phone screen. And when you look through the phone screen, you see something layered on top of reality, right? And hence Pokemon Go and these things. And you guys should try it out. Like, because one thing I was looking for is that AR can work very. You had a picture in your slide of a tower that was on a table. It would be great to see somebody use AR to show their quote unquote physical model. Because you know, a physical model, you know, you put it on your desk and it's physical. Like you could place your Revit model on your desk, but virtually, meaning looking out of your own two eyes, you don't see it. But just imagine you put your phone on a camera and you put your phone in a camera mode. And when you look on that table through the phone, you're seeing a model. So you can move around and look at that model on the desk. So your phones are a little small, but if you have an iPad example, especially, that can be really cool. But you have to look through the iPad's camera preview in order to see it. So that is what AR is. And in architecture, like, yes, we can build a scaled model, right? And have it on, a couple desks in the studio. But why not build your studio project at a 1 in 5 scale? You know how big a 1 in 5 scale would be? Like a two-story building would be like maybe 6 foot tall. Like you could actually show your model as this huge 1 in 5 scale model if you look through it through your phone. And the thing is, most of these are well, I won't say free, but close to free, meaning you don't need to buy a $600 headset. Most of us already have phones. You have applications out there that you can use. Most of them are trial, and of course, it's what most of them is probably some kind of subscription. But I'm saying this to say that that is one of the ways in which you can use AR. You can have, just like how you can have the little dinosaur on the ground in Snapchat, you can have potentially your model on a table, right? I don't know if we get the chance to experiment with that. Maybe in advanced computing too. We'll see how it go, right? And the only difference is that now with mixed reality, instead of you looking, you holding the phone, is almost like the phone is a transparent layer in front of you in the form of glasses. So you're seeing both reality and virtual reality at the same time, right? And you did give some examples, but again, a video would be really nice to show, okay, I hear you, but what exactly you're saying, right? Um, 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 who here drive? Um, who is a drive? Marville, you know about car?
Not really. Let's
That's
drive.
good. That's good. So if I call you over the phone, Marville, and um name a car that you drive. You don't have to be your car, any car.
Nissan Frontier.
A Nissan Frontier. No man, Marville, may I talk?
Yeah, man, that's same thing. It's Nissan
Oh, see,
Frontier.
shit, you know. Okay, cool. And let's say for example, something wrong with the engine. And I tell you that, oh, you need to check the catalytic converter wire. And you're like, okay, what the hell is that?
Exactly.
Exactly. And the example that was being explained in the group is that, Marvin, when you put on your glasses, you're seeing overlaid. When you pop the bonnet and you put on your glasses, you're seeing overlaid over the engine a highlight telling you exactly where it is in the engine. And that highlight is being projected in the glasses. So you're looking through the lens of the glasses, but you're seeing that it is highlighting to you where that device is.
Yeah.
And that is what MR is. It is mixing virtual reality and reality. So even if you don't know nothing about cars, right? Just by you having that layer that can tell you information, you can see, you can find, you can know things or do things that you don't even have the knowledge to do. So that is one way that those kinds of glasses are expensive. The Halo lens probably costs like about 3,000 US, right? If not more. And persons who work in factories, those are the persons that could afford it, and some of them use it. And let's say if somebody is responsible for putting together something complex, and for whatever reason they're not in for work today, you can just take anybody else from another department, you put on the glasses, and it shows you exactly overlaid over whatever you're working on, an engine or some kind of mechanical instrument. It show you exactly step one, take this thing, put it right here. Even though you don't know what this thing is, but it is literally visually holding your hand step by step, which is pretty cool.
Yeah, I think it is. I would have gotten the experience of the VR, the virtual reality in terms of with building construction.
Right.
Went to Autodex University and experienced it. So
oh, you tried it out?
Yeah, man. It is like
which one? Which one?
I don't know the name of it. I just know it was
virtual reality or
reality.
Augmented reality.
Well, let me tell you what it was.
Uh-huh.
Let me explain to you. So what happened is that you put the glasses on and then you get the two controllers,
Oh,
as if like you
VR.
are playing, what you call that, Mario game or whatever it is. But you're in the room. And so what happened is that you point wherever you want to go. The only thing you need to do is stand up and look. So if you look up in the air, you see the lights, you see the ceiling, you see everything. It's almost like you're in the room.
Right.
Right? You turn around, you see what's behind you, all of that. What you instead of walking though, that is where the controllers would come in.
Right.
Because obviously if you're in a stadium or in a extremely big building, for you to walk out that, being in the physical walking, that would be problematic. Can you get me hit up in a things?
Right.
But you have this thing, you point to the direction that you want to go, so it moves you to that direction. But when you move into a space, you can literally, you just move your head up, down, round, all over the place. You see where things are. So you actually feel as if you are in the building.
Right.
So you actually feel as if you get almost like a physical feeling, that how the space allow you to feel, be inside of it. So if you don't like the ceiling, you can say, well, listen, as a client or whatever, you can say, boy, or even as the lead designer or whatever it is, you can say, hey, listen, I don't like the ceiling, or this ceiling is ugly, or I don't think that this ceiling gives me what I want, or maybe it may be problematic to clean, whatever it is your issues are. You can then say what it is you want it to fix, because you feel like you're physically in the space experiencing it. So I think they call it
no, that's VR. That's VR.
Yeah, VR.
Right. And group 8, you did give that example, because you did show that example with Twinmotion, which is good. But then again, as I say, guys, you have to kind of experience it to see what it is. And it is not something that is out of reach. Twinmotion is free. All of us have Twinmotion. There is one more thing that I wish you guys would have mentioned. Yes, VR glasses cost a lot of money, but you don't have to buy a 600, 400 or $600 VR glasses, because you can buy one of those VR enclosures for like $10 or something. And you can what? You can put your phone in there, and your phone can act as a VR, right? So you can actually use your phone as a VR. It's not going to be as, what you call it now, high quality as if you buy the VR, but it's definitely usable. So I'm telling you this because I don't want you to feel like that most of these things are some, first world thing you only can get if you have money or whatever. The MR, these are things that you can download a free app, upload your Rivet model, and look through your phone, and you have your model on your desk. For the VR, Twinmotion has VR built in, right? If you have a headset, which is USB, you plug it in and bam, whatever you build, you see it in 3D. It's quite something else to see your project, to be inside your project. Trust me. Your project look nice when you have it on screen and, you're in God mode, spinning it around. But when you're actually there, yeah, you start to realize, oh crap, this space is really not as nice as I imagined it. Anyway, so those were some of the feedback that I wanted you to get. Right. Cool. All right. As for the next group, great presentation, guys. My concern with this group, I love the simplicity of the slide. My favorite thing was how the presentation really flows. Like you guys you're very in sync. You understand? In how you presented it, and that is great. And also love the simplicity of the slides and everything. Same kind of comment, and realize you guys didn't use a lot of, well, you don't really need a lot of videos for your thing, because you're talking about drawings. You did show example, but here's the thing now. I think somewhere in the presentation, you get a little bit confused between design and design drawings, because the question that was proposed to you is, is to compare the differences between design drawings, construction drawings, and presentation drawings. I mean, so sometimes you go a little bit into the process of designing, but the process of designing and design drawings are two different things, right? So sometimes you kind of got those wires crossed. So for example, one of the slides you were kind of showing like how, I think you had what, design, and then you were kind of giving the direction of a workflow, like you're saying you go from design to presentation to construction drawing. Am I right? Am I remembering the slide? You have the presentation there?
Yes, sir.
Oh, doing on time. Okay, right. Right. So I want you to, well, just pull up the slide there real quick. Right? So I think you defined the three types of drawings nicely: presentation drawing, design drawings, and construction drawings. But when you started to go in detail now, you started to mix the designing and design drawings. So design drawings, if I was to put them in the order of which come first, second, or third, technically presentation is first, then design drawings is next, and then construction drawings comes after that. So design comes first, but as I said, that's different from design drawings. Now this is really crucial because this links to a part of what you do in CSA. When you guys present at the end of the semester in your studio design or whatever, the type of drawings that you guys are doing are usually design drawings, right? Yes, you do a little bit of presentation drawings, right? But in architecture school, it focuses a lot on design drawings. And you did state the differences between them, which is good. But my main objective here to, as your lecturer, is to just make sure that you kind of absorb and you understand the difference between them. Because presentation is usually a very kind of simple form of communicating your idea. And you did a great job in saying to me that presentation can carry across the mood of what you're trying to communicate, right? So, right. So presentations are great for that. It can communicate the mood, the sun angle, the way the light hit the facade of your building, shadows, and those kind of things. Design drawings give you more information. Design drawings can even give you measurements and details and all of that. Design drawings can even look like construction drawings. The main difference when you go into the construction drawing part of it is that you have to deal with things related to regulation and legalities. You understand? You're focusing on things that will get your drawing approved. You're focusing on things like structural calculations, plumbing, electrical, all that kind of stuff. That is when you're going to construction drawings. Design drawings really come before that. So in a way, design drawings is almost like a strip down of construction drawing. Imagine you take a set of construction drawing, you take out all the electrical stuff, you take out all of the structural stuff and all of the permit stuff, the septic tank details, like the example that you show. If you take out all of that, leave your floor plans and elevations and sections, technically that's kind of design drawing. So sometimes when you guys present in your design studio, sometimes you do a little bit too much presentation drawings, meaning that information that would be needed to understand your design is missing. Anybody go up and present and the first question somebody asks is, so where's your north arrow? Nobody? Nobody forgot their north arrow? Or for example, let's say you're going into one of your major space in your design, but there's no way to know the size of that space. There's no dimension or there's no relative scale figure or something like that. So I wanted you guys to understand this so that when you guys present your design studio, I want you to aim for design drawings, not construction drawings. We don't need septic tank and plumbing and all that. But I want you to aim for design drawings. Even if you have some presentation stuff in there, that's fine. But the reason I said to aim for it is that if you aim for design drawings, you will have all the information that is needed to understand your design. All right, guys? Hope you're following me. Because this one here is very critical. Don't just go up and present and just show presentation drawings. You need that information that comes from the design drawing. You need things like your labels and your scale, your north arrow. You know what I mean? Anyway, that's enough of my blabbering. Let's take the questions. Let me bring up my little chart here. And questions from group 1.
Hello, sir, you hear me?
Yes, I am hearing you.
I have a question for the VR group, really.
All right, cool.
So AR, MR, and VR, they're used to help with like presenting ideas to clients and whatnot, really. So is there like a world where you see where like AI or some enhancements that can make VR better in, just like to make the whole experience on a different level, really? That's my question.
Okay, so the question is, do you see a world in which VR is better? I want to kind of break down that word. All right, I'm going to kind of help define better. So better meaning it's more accessible. I don't know. It look more real. Like when you say better,
Yeah, just all the
all
pros, really. Yeah. Like
okay.
how can it be better, or what would it take for it to be better?
Okay, cool. Well, in that case, I would say when you're answering the question, I want you to state one thing that is not so good about VR, and then how can that be? How do you see that getting better in the future? I think I will rephrase the question like that. So name one bad thing, one disadvantage with VR, and do you see that getting better in the future? Group 7? I mean group 6? No, I mean group 7? No, 7 is 8, is 8, is 8, is 8. Yeah. Who going to take it from group 8?
Yeah, I think I probably can try to answer that question.
Yeah,
I
name one
mean,
of the
try.
disadvantages. You did name a couple of them. So name one of them, and how do you see it getting better in the future?
All right, sir. So I'll put it like this. I'll say the next 2 to 3 years, significantly. I think as technology advance, there might be a lighter headset. Probably
Okay.
4K per eye becoming standard. Better hand tracking. Within 5 years' time, I'll say probably you'll get glasses size devices. Something more wireless performance. And if we should go probably 10 years, I think I think probably they will be creating stuff that more responsive to probably motion movements or something. But I think it all depends on how technology progress.
All right, good answer. I think that was a good one tackling the size because right now, all the pictures that you guys presented, you have a big bulky headset, which kind of adds to the fatigue. If any of you ever wear a VR headset, it's not super heavy, but then after you start wearing it for like an hour or two.
For a long period of time, it start become rather uncomfortable.
Exactly.
For me
Exactly.
personally, I can't have them on too long because then my ears start to ring. I get like a sensation in my hearing. So
Right.
I'll leave it up to how technology improve.
Right.
Because I mean, can't really tell the direction that technology is heading, specifically.
Right. But that is one area that could get some improvement. All right, good. That was question one. Next question from group two. Group two question going once. Group two question going twice. All right, group three. Question from group three.
Yes, sir.
Yeah, man, go ahead.
So my question is for group 7, I believe. That's with the drawing.
Right, group seven.
Uh-huh. So which drawing type is more client focused and why? And how does it help clients understand the project better as opposed to the other two?
That question was answered. Yes, it was, in my opinion. Yes, it was answered. Yep. Well, it's a group eight. I know that you mentioned that in your presentation.
Sir, that's group 7's question.
Sorry, me. Right, sorry, right.
Yes, sir.
So no. You have to wheel and come again. Because that question was answered for sure. So wheel and come again. That was group 3 question, right? So group 3, you need to come again with another question. Group 4, question from group 4. Question from group 4 going once.
Yes, group 4. Are you hearing me, sir?
Yeah, man, I'm hearing you.
All right, so this is for the VR group 8, I think.
Okay,
so
cool.
what are the key advantages of like using VR for architectural representation or representation compared to like more traditional methods like drawing or like having a physical model?
So one of them is immersive spatial experience.
Yeah,
So
you did say that.
yeah, it allows users to
You
walk
did say
through.
that. That one the
Answer that question.
too easy. That one the too easy, man. We don't come again. Question from group 5. Group 5 question going once. Group 5 question going twice. And group 6. Question from group 6. Group 6 question going once. No question from group 6. All right. Well, not true on the 5%. All right. Question from group 7 and 8 presented. So from group 9. Question from group 9. Going once. Going twice. No. All right. Question from group 10. Anybody from group 10 here? What's happening, guys? Nobody don't want this 5%? No? All right, let me open it back out before we head out. Back to what was it? Group 3?
Yes, sir. Group 3. I just cooked
Yeah,
up
man.
another question.
All right.
So this
Let's
is
hear it.
for the group 8 now, because I had to switch my question and think of a different one. So I know that the virtual walkthroughs are getting popular in America. Do you see a timeline of when that could come to Jamaica, or when, Jamaica will reach that stage where we will have virtual walkthroughs?
When you say virtual walkthroughs, you mean you put on the VR headset
Yes,
and
sir.
you're able to walk through
Mm-hmm.
through your design, to your building design. All right, good question. Good
Thank
question.
you.
Group 8,
I don't
when
think
the
that it is too far away. I can't say how quickly it will become something that is integrated into the architectural industry, but we already do have like at some arcades we have VR being like something that we use already out
right,
here. So I don't,
right.
it's not like too far-fetched, but in terms of like it being used in like maybe a firm, and maybe let's give it 10 years.
What
Is
is
that too
what is
far?
the hindrance? Why
What's the
you
what?
think why you think it's every firm
Because
that don't have one? Well,
okay, well, for one, I mean, yeah, we have moved towards already doing like using BIM and doing 3D drawings, but I feel like we just recently have gotten out of the whole 2D drawing because like well, a lot of the older firms, there are a lot of the old heads still there, and we still have a very big archive of the 2D drawings. So again, that's gonna be another steep learning curve to get to VR. So I wouldn't say
right.
it's soon, but I don't think it's too far away, you know?
Well, the answer to that is in two folds. So yes, you do have traditional persons running a firm. That's A. B, you guys are leaving CSC and going into these firms. So you guys need to say, hey, what's up? We can, especially when you have something that is very experiential. So, the drawings don't give it any justice. The nice rendering don't give it any justice. Like you have to be in this space. Then you guys need to sell it. But the biggest thing that will make we adapt it is the clients. Is the clients. The clients want to see stuff in 3D, so the architects are saying, hey, I don't know how to do 3D, but I need 3D because the clients are asking for it. So the biggest thing that will push us there is gonna be the clients. If people out here realize that, yo, I can be in this space and feel what it feels like, they're gonna expect that from their designers, just like how they expect to get a 3D from you. I think it's pretty standard now that most people, whether you're in a firm or you're just doing solo work for somebody, they want to see how it look, and they don't want to see drawings. They want to see 3D. So yeah. All right, that was a good question from group 4. So group 4, you're lucky in your point there. Yes, group 5, I think you had to re-ask your question too.
Sir, that one was group 3 just a while ago.
Oh, that was group 3. Oh, so it's
Yes, sir.
group 4 that need to ask again. Okay, cool. Group 4 going once. Group 4 going twice. All right.
Yes,
Group
sir.
5.
Yes, no, sir, sir,
Okay,
sir.
all
I'm
right.
still here, still
All
here.
right, cool.
Admittedly, I wasn't present for all the presentation. I joined class late, so I'm not sure exactly if the question I'm gonna ask was answered, admittedly. But in terms of like again for the VR groups, something like what future skills would architects in general have to like invest in or have to like learn like where what skills will we have to like start developing to learn in order to properly integrate VR within like the design process or like in presentation and everything.
Good question.
I can answer that one.
All right.
So I think if we're going to, make that transition again from BIM or like 3D or 2D drawings to VR, I think for one, architects need to have as we should, have a good understanding of spatial awareness and like being able to translate those 2D ideas or drawings to a VR space. I think also understanding your workflow would be something important to consider. And then also fostering collaboration and communication. And then just being familiar with the software itself.
Good answer
Yeah.
with the technology. Right.
Yeah.
So yeah, definitely. Workflow is important. You have to use a software that supports it. Twinmotion supports it, and I think Lumion, I don't know if them get VR yet in them thing. But Enscape definitely supports it. So you have to know your workflow. Most importantly, you just need to be exposed to it. Like some of these, like you guys, in a way, when you guys leave school, you guys use Revit and a lot of BIM stuff, so you know the advantages of BIM. Most of you have started your kind of architectural journey in BIM. So you never really started from 2D. You kind of just jump straight to 3D, which is fine. And then there's the inverse for the people who are mature in the field. They kind of started maybe with hand and maybe they are now into the 2D world. So when it comes to 3D, they're like, some of them might say, I'm not into this 3D thing, You do your 3D thing there, but they don't actually try to learn about it. Like, I think that principals of firms, they need to take a Revit course or take a ArchiCAD course or whatever. Not because they want to use it to draw and to produce, but just to understand where the advantage lie because they are the person in the driver's seat. So it's the same thing with VR. Like they have to take steps to so that when Marvel go in in the firm and Marvel say, hey, Mr. So and so, I carried my headset today and I want this project that we're doing. I did a little 3D mock-up of it. Check it out. You know what I mean? They have to be willing to say, all right, let me try it out and not say, it's a waste of time. I don't want to. You know what I mean? So yeah. So it's twofold. You guys have to push it, right? And they also have to accept it. Okay. And a good opportunity for you guys to do that. Sometimes it might be tricky in the firm, sometimes it's business only. If you guys have a personal project, an auntie or an uncle or some family friend asks you to, hey, I want you to do an addition for me or something. Like do it and make them experience it in VR. You know what I mean? You do your own investigations. All right, guys? Okay. That was what, 5? Was that 5 a while ago? Guys? Was that group 5 or group 4? Let's ask the question.
Group 4, sir. Group 4.
Group 4. Okay, group 5. Going once, going twice. Where's your question?
This here. So
Is
this
it
is for topic 7.
okay. This is group 5 asking topic 7.
Yes, sir.
Right, good, because I think we're out of VR questions now, because you all saturate that presentation already. So
Yes.
yeah, go ahead.
So if construction drawings are so important and as architecture students right now, they're mostly teaching us presentation drawings. Why don't they dive deeper into producing construction drawings in architecture school?
Woo. 2 points. 2 points for that one. It won't fit on my Excel sheet, so I can't give you 2 points. But good question. Yeah, go ahead, group 7. That question is for you. Not your lecturer, Question is not for me, it's for you.
Sir,
Mhm.
I'm going to try and answer that.
Okay.
I do my very best. We're doing For in architecture school, we're actually doing it's an arts degree.
All right, good, good.
I had a conversation with one of the master students, and the same question I actually asked that master student, and she said, because we're doing an art degree.
Right.
The whole purpose of architecture school is to learn how to design. Basically, not it's not focus it's not focused around teaching us how to use like the different softwares, and it was merely design.
Yeah. Hence why design studio is the big behemoth of a course. Right. But more importantly, guys, like this has been in debate for a long time. When you go out into the firms, they will say, Jano Star, Marvin, him can do stuff in a Revit, but him can't do construction drawings. And because construction drawings I need, start to be picking on you, Marvin. Right? But yet still in architecture school, we don't concentrate on construction drawings. So you might be saying, why is that? Because if the industry want construction drawings, then why we don't learn it so that I can better get a job or whatever? And there are a couple answers to that. One of them is true that you are in a art related course, right? And in architecture, you're not doing necessarily training. So like when you go to work in Digicel, you would do a training course and then tell you how to plug this in and what this mean or whatever. But you're doing a lot of learning. You're doing theory, you're doing design and that kind of stuff. For you to know construction drawing is mainly very pragmatic. It's more kind of training. What are the setbacks for whatever, and what is the density for this town, or what are the road width requirements? What is the septic tank radius, and all of these policies and rules and stuff like that, which are important to get drawings done and buildings built. But I guess you realize that we don't focus a lot on that. A lot of that is just covered in the theory, in construction, technology, services, and those things. But in those courses, it's more theory. Whereas design studio is hands-on, like you have to physically build a model, you have to go on site and all these things. So obviously we're more design oriented. But so that is one point with the whole art school. But I want to give you another, this is my personal understanding and also my experience. When you guys come out with an architecture degree, you can learn construction drawings. If you came out with a construction drawings degree, my belief is that I don't think you will be able to grasp what architecture is so easily. You follow what I'm saying, guys?
Yeah.
Yes, sir.
Architecture is problem solving, right? It's not about the Digicel technician who can hook up the cable. It is more about planning, what's the best place to give internet to? Um, um, how should how can I get the most customers for this internet service? Right? You get what I'm saying? You guys are learning how to tackle the big problems, and then you go out in the field and learn how to you do the training in the field. So when you go into the office, then you will learn about setbacks and submissions and road width and electrical whatever and structural whatever. You guys will learn that when you go into the office. One thing I can tell you though, because over the years I've seen people who do a drafting course. Because you can do drafting courses, There are many community colleges and places that offer drafting, and it shows you, it talk about how do you draw something, and they go into details and stuff like that. But I'm telling you, like, when you go into an office, nobody is going to sit you down and teach you how to design. That takes a lot of time, a lot of effort, a lot of tears, a lot of drama, right? Think about all your design crits that you have over the years. That experience doesn't exist in the work world. In the work world, it's about policy and drawings and road width and setbacks and, it's about the numbers. So really and truly, that is one of my personal, like, when I think about that question, I think it's better. What you guys leave architecture school with, you're able to add on to that the construction drawings and all the pragmatic stuff. And that's how you become like a really good architect, because it's almost like you learn the art and you go out and you learn the science in the field. All right. So anyway, as I said, that's my opinion. There's no rule book that says, oh, that is so. But I believe that that is a better route to take. All right. All right. I think, are those all the groups that asking the questions? We're just about wrapping up now. So that will be it for class today. Thanks for your presentations. We have 2 more weeks of presentations. So no, we have 1 more week of presentation. So remember, next week is a holiday, so there will be no classes on Monday. So group 9 and 10, you guys are presenting the following week. Please don't procrastinate, because you guys told me that you have a interim the next day. So between now, like, pretend that we have class next week, guys. Just pretend like we have class next week and just get the stuff done. And that way you will be good and clear for your interim. So I don't expect to come to class week after next week and there is nobody in the class because everybody preparing for a studio. Remember, you have an empty week. Please use it, plan your time accordingly so that you don't end up in the rush. All right, guys. Cool.
Sir,
Yeah, question?
can I just ask you something before you go?
Sure. Like a class question or just course related to the course?
Well, it's a question about the coursework that we're doing,
Oh yeah, go ahead.
project. So I had been having trouble with my terrain actually. I feel like it's
Oh,
because
all right, cool. You continue.
I feel like I'm not seeing absolute, which you mentioned in class. I don't know if that's the reason why my contour points are going all over the place.
Yeah, that definitely will cause it for sure. But you are saying that you are not seeing the absolute.
Absolute.
Let me go to one. Oh, I have it hidden right here. Hide. Right. So when I go to modify and you click on the points here.
Yeah, I don't know if it's my Wi-Fi, but the screen's very blurry.
All right. Hold on. It's a combination of Wi-Fi and the fact that I choose this. So let me uncheck this. All right. So when you go to add point, you are not seeing absolute. You're not seeing this icon. What version of Revit are you using?
It's Revit 2024.
Are you sure absolute comes up when you're under the add point, right? So you have to be on the
Yes.
add point.
I see subdivide from reset to subdivide to elevation, but no along surface or absolute.
I wonder if it's because, and you are using a topo solid, right? You're seeing a topo solid here.
Yes, topo solid.
All right, so here we're going to do. I might have to use your screen. Stick a pin on that question. Because I might have to bring up your screen. Anybody? I see some other hands. Gifford, what's your question?
Breakout room, sir.
Okay, breakout room. All right. Okay, so it's just two of you. It's just Shay and Gifford. All right. Any other questions from anybody? Everybody is okay with their model. Remember that we're not having class next week, so I won't be able to help. I mean, you can message me, and I can see what I can do, or email me.
Excuse me, sir.
Michaela. Oh, who was that?
Sir, I was going to ask a question, but I think somebody had a hand up, so we can go first.
All right. Yeah, put your hand up. Okay. Oh, Michaela, you have your question? No? Okay.
No, sir.
Oh, okay. Yeah, okay, go ahead.
All right, sir. I presented last week, group 5, topic 5, but when I tried uploading the presentation, it was not allowing me to. The file was over 10 megabytes, even when I zip it.
And
all
right, don't worry about it. I will increase the limit on it so I can solve that easily. All right, cool. Anybody else? Presentation here. Presentation. Okay. Presentation size. All right, cool. All right. The rest of you, everybody, you guys are free to go. I will stop the